Elliot Woods. You've seen his work doing sculpture last year, so it's someone we also like very much. So.
Hey. I'm Elliot. I've been here a couple of times. I did a talk 2 years ago. Was anybody at that, which was like next door? A couple of people? I'm going to presume you all were, so I'm going to keep out all the projects which were in that talk and just talk about a couple of things that happened since then. We were told we were supposed to talk 15 minutes, so I'm going to see how that goes. Okay, I'm from an art studio called Conçu, and we're two people, and we have two very different approaches to the kind of matter of adapting the physical reality to create artistic expressions. So we are working with technology, which is like light and computation, but also with physical materials to play with what really is material, what is really physical, and that kind of perception boundary, that thing about being human, of understanding the phenomena of the world from the perspective of a human, and how that's changing purely, mostly in a physical way. Okay, so we have a studio in Seoul, in South Korea, and sometimes it looks a bit like this, and sometimes, like when we're setting up something, it's a bit more of a mess, right? And this mirrors the general practical approach we have to our projects. That there's something that's physical, that's material, which is a channel through which the computers and the audience experience each other. So on one side of this, we have all this technology, which is kind of like where also the audience is, and then we have, on the other side, we have this kind of material, which is a channel through which we pass the artistic experience. And a lot of our works, as Kyle mentioned about his previous works, work with scanning the physical environment. So we need to kind of calibrate the way in which we're adjusting the world with our technologies, so we kind of have a scanning stage and then some kind of augmentation happening. So a really early example of that was this project called Lit Tree, which we have a physical tree, and we project light into it, so all these different pixels are landing in different places, and similar to what was going on with light leaks, we're recovering the location of those pixels in order to construct images. So in this case, because the tree is nebulous, all these pixels are landing in different places around inside the tree, and we're able to construct 3D shapes, 3D forms inside of that cloud of pixels that we now have control of. And also with this project, there's a second kind of effect of this, which is the light is obviously triggering the growth of the tree. So the tree is in this dark environment, and the only light that's available to it is that which gets fed to it from the projector. So over the duration of the exhibition, its shape adapts to wherever light has been sent to it. So part of the so we kind of embellished that by creating this relationship where people could reach in and have their hand mirrored as a kind of 3D cloud of light inside the tree to create a conversation between you and the this phototropic entity in the most immediate way. So you could kind of talk to a tree, perhaps, through something which it can react to quickly. And these projects, we talk about something called semi-materiality, which is things which are in the physical world and have some physical properties and some non-physical properties, usually something like a digital property. So physical property would be like, okay, it's genuine, it's measurable, it's familiar, it's human, it's touchable, and digital might be that it's mutable, it's changeable, it's copyable, it's deletable. And we have kind of one way of measuring like what the nature of these materials are, which is what we call the aesthetic of error, which is a concept from physics. Well, in physics, error means like how well something is defined, so the limit to which it exists, beyond which there is nothing, right? So like if you think about like measuring this table, there's a point to which where it doesn't actually make sense to measure it anymore, because actually you have all the information that exists in the universe, about that table, right? There is no more information to be had. And if you bring this back to art and design, there's a limit to how well you can design the table, which would to any kind of well, there's a limit to how well you can design the table, and beyond that limit is the material itself. So the threshold between design and material is this limit, which we call the error. And what's the aesthetic of that boundary between the two? So in new materials, like well, in old materials like photo, that was the grain in the photograph, right? The grain of a photo would show you no longer what was intended by the image, but the personality of the material itself. And this is true also of new materials. So we have this kind of catchy line. Well, it's not so catchy, but we have this line, 3 lines. Ego of the media is demonstrated through the vernacular of its deterioration. So the accent, the way in which it deteriorates, the attitudes of that deterioration demonstrate the identity of the material. Okay, so I haven't got much time. I'm going to skip through some projects. This project we didn't show last time, so I'm kind of putting it in here. It's a project about analog television and how for roughly like 5 to 8 generations, actually I should make that number, it's probably not true, but between the 40s and like about 10 years ago, TV, the standard for the television image hadn't changed. Right? There was like a standard for analog TV, maybe they added color and a few other features, but in the end it was 483 lines. So you'd see all the major events since the Second World War would be represented always in the same image format, right? So it's kind of a goodbye to that image format. Now we're getting a new one and things are changing a lot. But it's to say, okay, during all that time, everything which might have been important to you outside of what you could experience in a moving format yourself by being there would have been experienced through these lines. So these installations are very time-consuming processes of constructing something physical. And did anyone see the installation in Skopjeton 2 years ago? We had with the strings, some of you? Okay, so we have this very nebulous network of strings hanging in the air, which is projected onto. Following that project, we went in this different direction of making everything very regimented and ordered. So it starts with this analog TV image, we blow it up so it's 16 meters wide, and then we fold it 15 times so it fits into the gallery space. But also because we have these folds, we've now got this thickness, and we have a depth into which we can draw, so we can start to draw into 3D space using this also. Do I have audio? So often with our works, we're developing a canvas which uses technology inside of it, and we're working with that canvas to create something visual. This is the second version of the project, which just opened in South Korea. Okay. We've worked a lot with this motif of a sphere or a circle, or also the moon, mostly because it's kind of like we're talking about making something physical that's between this realm of digital and physical. And the most simple form in the physical world when you're talking about physics, usually is the sphere. But also, there's this idea of like looking out at the moon. The moon is this thing which kind of reflects what the nature of the Earth is. You're seeing it in the sky, and it's the only thing in the natural sky that you can see directly, which shows what shape the Earth is, right? It's like you can see the nature of a solar system by looking at the moon. Anyway, so we have this project which is trying to render moons into space by using wind and fabric. So we call this a wind painting. And as the fabric passes, like just blowing on the rooftop here of our studio, and just blowing in the wind, and we're tracking it with a 3D camera. And as it passes through this virtual moon, we're sending projection to that intersection. So over a long period of time, if you take a long exposure photograph of that, you'll capture all of those moments of time together in that long exposure photograph. So you render the moon to the image. I'm interested in playing with this concept in areas, in locations which have some kind of absence. So here is an incinerator where you burn trash, right? And it was decommissioned about 5 years ago, and we wanted to play around with, there's this huge absence in this place because it's this enormous, brutal building, which is kind of emptied of all its purpose. So we're kind of bringing something back into there. And one thing we found in general was, if you want to make something visible in the world, you have to give it a surface. Like the way our eyes work is that you've got a line that comes out of your eye, and it continues until it hits the surface, right? And this leads to this general principle that if you want to make something visible, it has to be given a surface. So what we do is we're giving this moon a surface which travels through space, and the surface is the boundary between this virtual and physical world. So here is just this is the video of us moving the fabric. Then afterwards there's a little simulation which shows what would happen if that was a long exposure. So here it's kind of adding these frames together as the fabric progresses. So you can kind of get how the moon is occurring, right? So this was kind of a bit of a messy job. It was so this place, like I said, it hadn't been used for years, and it's just full of dust and rubbish. So it was like working 20-hour days for a week to clean it out and then install all these bits of fabric. We worked on 3 different locations to try and reactivate, like where people were walking and standing, where there was this kind of air purification. So it was like a lot of kind of steam and activity in here, and the bunker itself where all the trash was being kept. And this was rather than it being an installation project, as all of others are, this one was a photography project. But we also wanted to have for the audience to be able to see this fabric. So for the final flag, we dropped it down into the bunker. Let's get through this. Then here there's like there's air being brought into the building. So we're pumping air from outside that's kind of the new air coming to refresh the building as it gets reborn as an art centre, which is what is going to happen afterwards. Also, it's quite necessary to pump a building full of new air when it's had trash in it for a really long time. And then you'd see this at the exhibition, there was a balcony at which you could see the fabric moving. And there's the kind of tracking camera and projectors which are hitting it, and there's the photographs. Okay, I'm just going to talk about one more project, which we hadn't done when we came last time, so I can probably spend all of that one. So we started with the Impressionists and their obsession with light, and we wanted to kind of, conceptually we started with this. And there was two aspects which we're really interested in. One was kind of this relationship with light and this obsession with light, and the other one was the relationship to the camera. So as the camera came out, before the camera, a lot of these paintings were oriented around a viewer in a special way, so that the person was unique in the image, and the world was laid out around them. And then when the camera was invented, we started to get these viewerless images, so images without this kind of this hierarchy of kind of religious actions happening around somebody, but more kind of studies of focus and studies of light. And we're living in a time where cameras are also being very redefined. There's lots of new ways of approaching what an image is and how it can be captured. And also, this idea of the special viewer, it's usually like when you think of a screen or when you think of like something that's kind of operated, then it kind of, there's a relationship there between that and this kind of way of working, and then something which is like a viewerless image or something we're interested in. So the principle is, there's a technical principle called light field photography or light field projection, where instead of just using one point in space to capture from, you have many, many points in space, or many, many points in space to project from. And the idea was, if we can get beams of light from all these different points in space, each one of them will be quite dim, but as they collide, they'll make something significant. So this is the first test we did. And the trick was, instead of getting 400 video projectors, we were going to use mirrors to split the light. So if you imagine that the bit of projector that lands on this circle over here, if we hit the left-hand side, then the boom goes this way. And if we're at the bottom, the beam goes this way. So we can use these little mirrors to split one projector into many, so we could have these kind of many points to come out from. And these are just these mirrors you get in the corner of a car park, or a spa or whatever. And then with a little help from some people who owed us a favor, we cut these up into hexagons and made this like light field lens, this kind of sheet of mirrors. But also we knew that like we're gonna be rendering this thing into the air. We're gonna be making this kind of collection of projection into the air. But we're also going to have this physical counterpoint to that object that's being projected, which is the physical thing. And that's what's going to connect the viewer with the virtual object. So we're very considering how this was constructed and how it would appear as you came close to it. Here you can just see, like when we're in the factory, we're blowing some smoke across it, and you can start to see what the mirrors do. If you just watch now, you see the peaks that appear, so you can see that there's a lens happening, right? Well, one of the biggest problems with doing a project like this is it's just physically really big, and you can't just put it on a spec sheet and say, please be there, please have it ready when we get there. So all of this has to kind of come apart and be created. Back together. So when we have this constructed, we have this light field lens, this ability to project from many different places. As long as we have some kind of projectors on top, we're going to hit it, right? But actually we need quite a lot of these projectors. We need like 8 of them, and they need to be really bright. So again, we start to have this problem that it could be very, very expensive. So we discovered this hack where we could take a normal video projector, which has got this component inside, and this component allows it to render color by filtering the light, so that at certain points in time it could project red because the red filter is in front. At other points in time it will project blue. It does this very, very fast to make the image. So what we did was we broke it and threw that part away and then put it back inside the projector. So the projector now thinks it's projecting in color, but it's actually just much brighter in black and white. And we did some tests about this, and you know, what are the results? And kind of what we found was that this is what these steps are for. What we found was like there's a lot of projectors down here, which are like cheap ones, and they're supposed to be used for a classroom or like an office or whatever. And then there's a lot of projectors up here, which are kind of like what we're seeing up there, like an installation projector or a venue projector. And this is a graph of price, money, versus brightness. And what we found was this is like 7 times more expensive, right, to get twice as bright. But if we can move all these to here, then you get the point, right? So that's what this project is all about. And we've got some documentation online about how to do it, and we also do some workshops sometimes on that. Okay, so now we've got these pixels coming out, and they're all landing on these mirrors, and they're all bright enough. The next thing we have to do is we have to know where they all are in space. So you imagine like all these projector pixels come down, hit the mirror, bounce off in some direction or other. And we want this kind of information. We want to know where is the pixel and where is it traveling to. So therefore we can start piecing things together by choosing the right pixels. And we use this technique called structured light, which we first used on literary, but now it's kind of coming through in a different way. And we bounce the light off the mirrors onto a screen and see where it hits the screen. And we do that multiple times, and then we're able to build up this image of where all those rays of light are in space. And to do that, we create this tool called Ruler, which some of you might come to tomorrow. Right, yes. Is that a fact, yes? Or okay. So tomorrow we're going to do some stuff with Ruler. Partly it's going to be using Ruler and like doing some calibrations, and the other part is like looking inside it and seeing how it's brought together, which is this very like what's it? Very high level kind of abstraction of working with openFrameworks. So here's Ruler, and what you do is you make nodes. So we made a camera node. And inside this node is openFrameworks code. Maybe we'll have focus find it. This is also demonstrating the sound design. So Robert Henke has provided the sound design for the latest version, and this is an example where it'll tell you what's in focus by the sound. Not for a good example, sorry. But anyway, the idea is to try and wrap together a lot of what we were making for all these different projects into reusable components. So we were making something that scans, we were making something that calibrates in 3D space, we were making something that's like a database or whatever, and the idea is to kind of make those all into these nodes that we can plug together inside Ruler. And this is all open source and it's all free, and then if you're an openFrameworks developer, you can write your own nodes that take these as inputs, and it's made in kind of an easier way as possible. And also, some people are using it for like show control. So they have like many openFrameworks developers making like either a drone show or something like this, and then they use Ruler as the 3D world, which everything comes together in. Because there's kind of constraints over how you define what a node is, different developers can more easily collaborate together. Okay, let's get back to the presentation. So yeah, there's workshops on that will be tomorrow. Okay, so back to light barrier. The kind of story is about like the light barrier is this boundary between light and material. So something that's material can't travel like light, right? And there's other aspects of the light barrier, like equals mc squared, which say what happens when you want to transfer material and light. Things that stop becoming physical and start becoming, in a way, digital, or vice versa. So the story is about this form that travels through the light barrier and becomes material. So it's a digital form that becomes material through this technique. So I'm just going to show this video, a couple more slides. there's kind of some big smoke machines out there. So this was in Chicago. I'm looking at the hotel window, and I think it's like a laundry or something like that. And it's making quite a lot of smoke. And it goes across the whole city. It's like one big fog machine. We've all seen this kind of thing, right? You know, you can get lasers to go pretty big. This is like 10 watt lasers. So 10 watt lasers are really expensive. If you wanted to make something like light barrier with 10 watt lasers, it would be impossible. 1 watt lasers are really cheap. But thanks so much for listening and watching.